Hey everybody, this is Mrs. Slauson. I will be doing the spiral review first. So let's go ahead and get started. So a good thing to have in front of you would be your different various toolkit pages because we are in the spiral piece. So in our first example, we will be graphing a cubed shape, which when I look at my toolkit, that means as far as my x's, I'll be using these values. And then because I will be cubing these values, here are the y values. Okay, so let's talk about what's going to happen in this shape. So we are going to have a flip. We're going to have a left 2 and a down 1. So what I can go ahead and do right now is take my 0, 0 and go left 2 and down 1. And then I will take this flip value of a negative, and I'm going to change all of my y's so that they're negative now. So negative y, so we're going to make this positive 8, positive 1, negative 8. And if I consider this my starting point, I can now go left 2, up 8. I can go left 1, up 1, right 1, down 1, and then right 2, down 8. Whoops, not there. There. All right, and then I got this shape. All right, real quick for the arrows, there is nothing stopping these. So this arrow is going to be negative infinity, infinity. This arrow is infinity, negative infinity. And I'm going to go through the different extra things they're asking me to do. So the first thing they're asking me to do is find out where this is negative. So let's try to get a color that's going to work. So this area is where all my y's are negative. So what I'm going to want to find is where it crosses the x-axis, which is negative 3, 0. And now it's negative from negative 3 to infinity. This is asking if x is 3, but we are going to change that. This is going to be a negative 3 instead, so I'm purposely changing that, okay? And that negative 3 is going to be 0. And then on the next one, I'm going to do where y is 7, so that gives me an x value of negative 4. And then my average rate of change, which is my table stories. So x is in the bottom, y is in the top. All right, so I already have the x's, so I'll do negative 1, take away negative 4, which is going to give me a positive 3. And then I'm going to find their matching y's. So negative 1's matching y, if I go back to my graph, is, excuse me, negative 2. And then I'll take away negative 4's y value, which is that 7, positive 7. So when I subtract, I get a negative 9, and when I divide those two, which is what I prefer you to do, there's my average rate of change. All right, let's go to the next one. Okay, so our next function is a piecewise function, and we will be graphing 2 lines. So let's start with our first line. And we're going to have a y-intercept of negative 2 and a slope of negative 2 over 1. So my line's going to be going downhill. When I'm ready to graph the next line, I'll have a y-intercept of 1, a slope of positive 1, and that line will be going uphill. And I don't want to graph the full line, I just want to graph the pieces of it. So I'm going to go to my x less than 2, x is greater than 2 piece, which is right here. Let's see. And I'm going to have this wall restricting my domain. And my 1x plus 1 will go on the right side. And let's see, the negative 2x minus 2 will go on the left side. So I'll start with the negative 2x minus 2. So here's my y-intercept of negative 2, then up 2 over 1, getting a downhill look. Go up to that green line. And because it is not underlined here, I'll leave this as an open circle. And now for my orange one, I'm going to begin at 1, and then I'm going to go up 1 over 1. And I only want the part of the orange line that's, or the orange points that are on the right side of that green line, so I'm only going to connect those. And because this one is underlined, I'll make this a closed up circle. All right, let's go to the next one. So I'm going to do a little erasing here so I can read what's going on. So I need to see where is x25. So x25, so this x being 25 fits in here because 25 is bigger than 2. So because the 25 is greater than or equal to 2, I'm going to put 25 into x plus 1. And that's going to give me an answer of 26. So on the next one, I'm given y values actually on both of them. So I'm going to see where's y4. So y being 4 is here and here. And so those give me 2 x values. One of them is -3 and the other one is a positive. Oh goodness, what would that be? A positive 3, I think. All right, and then on the other one, I'm going to have an x is 7, or I'm sorry, y is 7. So that's about here and about here. So the second blue dot, I can definitely tell what that is. That is x is 6. The other one I can't tell quite. So since it's part of the negative slope line, I know that -2x minus 2 should give me a y value of 6. So I'm just going to go through, not 6, sorry, 7. I'm just going to go through and solve for that problem. So I'm going to add 2, and then I'm going to divide by -2, so the other amount is -4.5. All right, let's look at some of these. So, in our first one, we are going to be simplifying the radical. So, I kind of talked to you guys about this. This is where you could make houses. So, non-checkmark numbers and checkmark numbers. Go ahead and just break these all up. So, the things that are perfect immediately that can come out are the 16 and the x to the 4th. This x is going to be stuck in there. There aren't enough x's to come out. But this 27 I can break into 9 and 3, and then the 9 can come out and join this. And so at this point where I'm at is I have, on the left side of the house, I have 8 over 3x squared, and then I still have a square root of 3 in the denominator. So what I have to do is fix that square root of 3 in the denominator by rationalizing it. So my numerator just becomes 8 times the square root of 3. The denominator becomes 3x squared with the square root of 9, but the square root of 9 is going to become a 3. So a regular 3 joining the 3 that was already there. And when I'm done, I get 9x squared in the denominator. All right, the next one, we're going to take adding, subtracting, really picky. We need like terms. So I'm going to take the 4 square root of 27. And I'm going to break it into 4 root 9 root 3, which becomes 4 times 3 root 3, which is 12 root 3. And then I'm going to do the same with the 48 and 3. So it becomes 3 with 16 and 3. That becomes 3 with a 4 in root 3, and that becomes a 12 root 3. And then I'm going to take the final results that I got by simplifying and add them. So when I do that, I get 24 of these root 3s. Okay, number 5. So I'm going to distribute. That's going to give me the square root of 16. And that's a nice number. That's 4. And then I'm going to distribute again. I'm going to get 5 with the square root of 36, which is also a nice number. And then I can just start simplifying this and get to 34. All right, the next two are from our last chapter. So in the first one, multiplying, I'm going to start to look for things that I can cancel out. So I'm going to factor everything. So the x squared minus 16, remember that's our difference of squares. 4x squared, I'll break into 2x, x. 2x to the fifth will become 2 with 5 x's. And the x squared minus 8, if you need help factoring, you'll need factors of negative 8 that make negative 2. And that's going to be a negative 4 and a positive 2. So I'm going to get x minus 4 and x plus 2. And now we are ready to cross off. So an x minus 4 will take out an x minus 4. A 2 will take out a 2. 3 x's will take out 3 x's. And then when I'm done, what's left in the numerator is a 2 and an x plus 4. And in the denominator, I'm going to have 2 x's and an x plus 2. All right. Let's go to number 7. So here we are adding and subtracting fractions. So that's where we need to get common denominators. So this first denominator, another difference of squares, this turns into x plus 2 and x minus 2. The other one I will make the x out of. So here we go. I need factors of 14 that make 9. And that's going to be a 7 and a 2. And if you can't see the least common denominator, that's where we make our little table. And I have x plus 2, x minus 2. I have another x plus 2 and an x plus 7. And if I bring everything down, this is what all three things will need. So I'm going to do a little racing at the top because I have a lot of room. And I'm going to take the first fraction, and it's missing the x plus 7, so I'm going to put it on the bottom and on the top. The next one is missing an x minus 2, so I'll put it on the bottom and on the top. So as far as my numerator goes, I started with a 5, and I gave it an x plus 7. And I started with a 2 and gave that an x minus 2. So again, just going to do some erasing. I'm going to have 5x and 35. I'm going to have 2x and negative 4. I have to add these up, so I'm going to stack those like terms. And then I just have to remember that when I add and subtract fractions, that the denominator goes along. So we're going to, again, just do some more erasing. So I will put the common denominator of x plus 2, x minus 2, and x plus 7, and this is the final answer for 7. All right, number 8 is a simple evaluating. All I have to do is take the fact that x is 6 and put it in the absolute value bars. And these are bars, not parentheses, so I don't distribute the 2 in. I'll just subtract here. The absolute value of negative 4 is 4. Then I can multiply, and then when I'm done, here's my answer. All right, jumping to the next page. So first, 15 is a repeater, so let's just cross that off. But we've got these 6 functions at the top. Oops, I totally bypassed that, and we're just going to use them in different ways. So in the first one, this is a composite or composition function, and it says f is going to go into r. So essentially what's going to happen is this is going to go to r's function. Instead of x being squared, I'm going to have 4x plus 1 squared. And then still the minus 3. The directions do say go to standard form, so that means I'm going to take 4x plus 1 and multiply it twice. So I'm going to get 16x squared. I'm going to get 4x. I'll get 4x again. 1. Take away 3 gives me a final answer of 16x squared plus 8x minus 2. All right, the next one, little different. So what I'm going to go do is go to f's function. So f's function is circle, and I'm going to put 6 in. So that gives me 24 plus 1, which is 25. And now what I want to realize is there was a k hanging out on the outside the whole time. So kind of bring this along. And now I'm going to go to k's function and put 25 in. And when I'm done, I get 6. All right, on 11, we are going to determine if f of x and h of x are inverses of each other. So f of x, h of x. So in the first situation, I will take h and put it into f. So all of this is going right there. So I'll have 4 with 1/4 x plus 1, and then another plus 1. And I want to simplify this and see if I can get to x. So I'm going to have an x plus 4 plus 1, and when I'm done, I get x plus 5. So I already know the answer is no, they are not inverses. If you do the other one first, and we take f and put it into h, then f is going to go right there. So I'll have 1/4, and for x will be 4x plus 1, and then still another plus 1. So when I distribute, I get x plus 1/4 is plus 1, which makes x plus 1 1/4. So again, no, these are not going to be inverses of each other. Next part, we are going to work with the functions h of x and k of x and put different numbers in and then solve them. So for h of x, I'll take 1/4 of 8, which is 2, add the 1 and get 3. For the k of 49, I'm going to put in square root of 49 plus 1, so that's 7 plus 1, which gives me 8. And then I'll just bring this plus side down, add these up, and I get 11. And we're going to finish up this page and then call it good as far as the video goes for this page. So on the next three actually, we will be working with different functions and finding the inverses. That's what this -1 says. So I'm going to go to m's function and find the inverse, which means I'm going to take m of x, which is y, switch it into x, and I'll take the x and switch it into y. And I'm going to get this new y by itself. So the first thing I'm going to do is add 7, which leaves me with this. Then I will square root, which leaves me with this, and then all of this side is square rooted. And then the last step is I'll subtract 5, so I'll have the square root of x plus 7 in the check mark and minus 5 not in the check mark. And then to finish it up, I should write the inverse notation. All right, so now we're going to find the inverse of k of x. So k of x is this. Let's see. So x becomes y, and k of x, which is y, becomes x. And now I'm going to get this new y by itself. So I'm going to subtract 1. And then to get rid of the square root, I'm going to square both sides. So that gives me y, and that gives me all of this. And as far as I'm concerned, you could leave it like this if you want. If you want to take some time and actually multiply that out, then you would get x squared minus 2x plus 2, and then that's going to equal the inverse version of the function. All right, just a few more. So let's go to 16. So on 16, I'm going to take r of x, do the same thing. So that r of x is going to, which is y, becomes x, and the x of x squared becomes y. And now I'm just going to get y alone. So I'm going to add 3. And then to get rid of the squared, I'm going to square root. And then that's it. It would be better to write r -1 of x, but hey. Okay, next one, we're going to go to r of x, same equation, but the regular one. And we want to make y, or r of x, equal 21. So it's going to be 21 equals x squared minus 3. So I'm going to add 3. It's one type of x. Then I'm going to square root. And this is where it says simplify the radicals. So I want you to realize that 24 can break down into 4 and 6, and you can get 2 squared root of 6 plus or minus because we did solve. On the next one, I'm going to go to g of x, and I'm going to put a negative 17 in for x. And when I take the square root of a negative number, I get 4i. Now, I'm not solving, so I won't say positive or negative 4i. I just say 4i. All right, that is the first video. We will pick up the second page in the second video.